Let's compute OR probabilities with overlapping conditions. Meaning, what do we do if we have two things that share common elements? Think about this Venn diagram here. We've got item A with 1, 2, and 3, and then item B with 3, 4, and 5. 3 is a shared element. So if we think about the probability of A or B, right? Generally, we think, okay, with OR probabilities, we add. But if we add this plus this, we have now counted the 3 twice. So we always talk about subtracting the overlap. So the probability would be the probability of A plus the probability of B minus the probability of A and B. Because we're saying we're going to add 3 here and here, but the overlap is 3. So by subtracting a 3, right, this is 3 plus 3 minus 3, these would cancel out, and we're just left with 1, which is what we want. All right, so the formula is probability of A plus the probability of B minus the overlap. All right, let's jump in. My pen stopped working. Okay, you roll a 6-sided die. What is the probability of rolling an even number or a multiple of 3? Okay, so probability of an even or a multiple of 3. So we're going to find the probability of an even number plus the probability of a multiple of 3 minus the probability of even and a multiple of 3. Okay, well, what do these mean? So let's start with an even number. Well, 2, 4, and 6 are even numbers. What about multiples of 3? Well, that's 3, 6, 9, 12, 15. Those are all multiples of 3. Okay, great. So looking at the probability of even, there are 3 of them out of 6 total, right? Because it's a 6-sided die. Probability of a multiple of 3. Well, there are 2 multiples of 3 out of 6 total. Now, how many numbers do these two sets share? They each have a 6. That means they share 1 out of 6 total numbers, right? Because we counted 6 twice. We counted it as part of this group and part of this group, which is not what we want to do. So our denominator is 6. That's great. We take 3 plus 2, which is 5, minus 1, which is 4. That reduces to 2/3 or 0.667 rounded to 3 places. Let's do some more. A standard deck of cards has 52 cards, represents 4 suits: clubs, spades, diamonds, and hearts. Find the probability of drawing a face card or a spade. Okay, so probability of a face card or a spade. Now, because there are 4 suits, there are 13 of each suit. And they range from an ace, 2, 3, 4, 5, all the way up to 10. And then they have a jack, a queen, and a king. There are 13 cards in each set, right? Okay, so face cards. Face cards are jack, queens, and kings because they actually have people on them with faces. That's why they're called face cards. So there are 3 face cards in each suit. There are 4 suits, so there are 12 total face cards. Okay, so we're calling probability of face plus the probability of spades minus the probability of face and spade, right? That's our formula. Okay, so let's play. There are 12 total face cards. So the probability of a face card is 12 out of the total 52 cards. I said earlier, there are 13 cards in each suit. So the probability of a spade is 13 out of 52. Now, how many of these cards that are spades are also face cards, right? Face cards and spades. Well, there is the jack of spades, the queen of spades, and the king of spades. So there are 3 that are both a face card and a spade. So we are going to subtract the overlap of 3 out of 52. So when I do that, 52 is my denominator. 12 plus 13 is 25. 25 minus 3 is 22. This reduces, they're both even, so 11 over 26 as a fraction or as a decimal 4231. Right? And now let's play with a table. So again, we have I shouldn't say again, different video, but we have students wearing glasses, yes or no? So these are glasses. And what color shirt are they wearing? Green, red, or blue? Okay, so first let's find the probability of green or no. Now, the big thing with a table when you're playing with the or is you got to think about what you're asking. Okay, so, ooh, wrong button. I want to go to my, just kidding, I can't talk and highlight at the same time. All right, let me change colors. So, green is here, no is here. Now it says green or no, so I want, this is a green, this is a green, this is a no, this is a no. I don't really care about the totals, I just want the greens and the no's. So, if you think about it, we've got 56 total, and I've got 17 plus 6 plus 12 plus 9. That represents greens or no's. So I can add those all together, and I get 44 out of 56, which reduces to 11 over 14, or 0.7857. And if you say, stop, that's not the way we did it before. Well, okay, that's, oh no, that's not what I wanted to do. Think about doing it the way we did it before. Probability of green is 23 out of 56. The probability of no is 27 out of 56, and green and no would be this 6 right here, 6 out of 56. Both ways, we get the same thing, 44 out of 6. So my point with this is if you have a table, you have options. You can do the counting part, or you can just do the formula. So the probability of blue or yes. Okay, well, here's blue. So probability of blue is 17 over 56. Probability of yes, well, here's yes, right at the top. So that's 29 over 56. And which ones did I like double, right? What is yes and blue right here? Yes and blue. So that's minus 8 over 56. Don't forget to subtract the overlap. And that leaves us with 38 over 56, which reduces to 19 over 28, which is 0.6786 as a decimal. So don't forget, with tables, you have options. You can count, or you can just add them all up. I mean, do the formula. Either way. Thanks.